let's take a look at these lighted. You see we've got the 4 of them here for our 4 tracks. We're using the built-in LED that comes with it lighted. It's right on the board. But there's also little holes on the bottom side here. There's 4 of them, one for ground, and the other 3 can go to up to 3 LEDs. So these can drive 3 LEDs using connecting wires to these little holes. They can drive 3 LEDs in a control panel or a building or somewhere on a piece of rolling stock. And they can be used in 3 modes: accessory mode, loco mode, and signal mode. And of those 3, the accessory mode is the simplest, and that's how we're using these here. You can turn them on and off with a single command. Like right now they're off, but let's look at the first one, which is accessory 1. So I'm going to say I'm going to push the select accessory button on my power cab, and it's already defaulted to 1, so I'm going to say enter, and then it gives me my choices. I'm going to push 1 to turn it on, and you can see it came on. So I'll say select accessory again, and it's defaulted to 1. I'm going to say 2 to turn it off. So that's how we can control these. We just need 1 command to both address the number and turn it on or off. And in the mini panel, that can be just 1 command. You can do more with loco mode, but you have to use 2 commands. Just like normally a loco, you got to select the loco number, which in this case you're selecting a lighted, and then you got to tell it which function, what the function value is going to be to set it, which is 2 commands. Now we'll try programming a different number for this lighted number 1. And what they tell you to do in the instruction manual is you push this button. There's a little, each one of these things has a little button. Let's back up for a second. These things are daisy chained together. That's what you tell, what the NCE manual says to do with these, or you can do. You can daisy chain them. This is track power coming in from the power cab, and we just hooked onto the first one and then daisy chained down to the other 3, and we could keep on going with the whole bunch of them. So to change the number of the thing, they tell you to push the little button. Each one of them has a little button on it, which is kind of hard to see at the light level, but it's down here. And I push that button. Now that's blinking. It's going to give us a minute. So we're going to send to the select accessory command. So I'm going to say select accessory. I'm going to say 11. I've got accessory 11 in here. Enter. And I'm going to say 1 for on. Enter. So that should be changed to accessory 11 now. Let's see if we can turn it off. We'll say select accessory. Defaulted accessory 11. Enter. We're going to say 2 for off, and it turned off. So now that thing's operating as accessory 11. So that's how you change the accessory number on these. You push that little button to put it in programming mode for the number, and then just select an accessory. And whatever accessory you send to it, that's the number it becomes. Next, we'll see if we can change the lighting effect in the manual. The lighted decoder manual, which is what I'm sitting here looking at, gives us a list of about 15 different lighting effects we can have, which are here. And for the white LED, which is what we're working with, it's CV137, and they tell us to use the it's a weird name, the ops programming accessory CV. But on our cab, we go into programming mode, and then they say push the 7, which gives us the ops program accessory CV. Hit the enter to select that. Now it says accessory address, and since we changed this light it to 11, we're going to push enter to select 11. It wants CV number, that's 137, so we're going to say 137, enter. And in our value, we're going to put in a rapid flash, which is 15, so we're going to enter a value of 15 for that and press the enter key, and it took it. Now we should be done. We're going to say escape to get out of the programming mode. So if we turn on accessory 11, I'm going to go select accessory number 11. I'm going to push a 1 to turn it on, and you can see now we got a rapid flash effect instead of a steady state, and that's the same way we programmed this number 4 for the analog track to be a slow blink. So let's program that back to let's program it to a slow blink. So we're gonna push the programming button, and we're gonna push the 7 for the ops program accessory CV, enter, accessory address 11, program CV number 137, enter the value, and I'm going to go to a slow blink, which a slow flashing, which is a 2. So I'm going to enter a 2, enter, and it took it, and you can see now that's doing a slow blink. So that's how we can program. We've just gone through changing the number of one of these lighted decoders, and we've gone through checking how it blinks. And they got options like flicker, rotary beacon, railroad crossing, random on-off blink, mercury vapor, street lighting, rapid flash, which we've done, slow flashing, which we're doing now, and study on, which is where we started out from. Now here's the 5th decoder over here controlling this status light. This decoder is physically the same as the 4 we just looked at. It came with the same package of 6 I ordered, but this one we got the 3 little holes on the side. We've got those connected to the wires going to this block signal light. We've got the green and the red wire connected. There's an empty hole where you could connect the yellow wire for a yellow light, but I don't have a yellow light. And we have to use this decoder in Loco mode, and the reason is using them in accessory mode like we demonstrated a minute ago, all 3 of these turn on and off at the same time in accessory mode according to the instructions. But if we use them in Loco mode, we can turn these on and off individually. And right now I think that's the 2 input is the red. If I push the 2 button on my controller, if I push the 2, that turns that toggles that red light. You can see that's every time I push the 2, it's toggling the red light on and off. If I push the 0, it's toggling the green light. It's toggling the green light on and off when I push the 0. And in fact, you can have them both on. You can see now the red and the green are both on. And if there was a yellow light, we could use the F1 function to turn that one on and off. So this is how we operate our status light using the same lighted decoder, but using it in Loco mode with the individual wires connected to it. Now we're going to see if we can change the number of this decoder. It's going to be similar but somewhat different than the previous one. Since this is operating as a Loco decoder, we're going to start out the same way. We're going to press that little button on the decoder till we get the flashing light. and we're going to change this from 999 to 888. So we're going to say select Loco 888, enter, and then we're going to go into program on the main, enter, program Loco 888, enter, CV number 1, enter, give it a value of 1. You can see our flashing light on the decoder went out, so we should be at our new number. So now we're set to Loco 888, and if we push the 0 button, you can see the green light comes on. If we push the 2 button, you can see the red light comes on. And notice the light on the decoder, the white light that's built-in LED on the decoder, operates along with the green light output. They come on together. And NCE tells you in the instructions you can cut, if you don't want this light coming on, you can cut a trace so that this light will stay off, and just this green light here would come on, but this one wouldn't come on anymore. Then the third mode you can use is a signal mode, which is probably the most powerful mode, and I'm on the page in the instructions for the signal mode, and I think you can do these things here, the first 7 aspects, using the mini panel. I don't believe the mini panel can send all these commands, but I haven't used this at all. I don't need it for what we're doing here. Let's take a look at the wiring diagram for this setup. And this drawing and the other documentation can be found on the documentation website at AutoControls-dot-wordpress.com, which is part of the AutoControls-dot-org website, and look for album 849 and video 849. What we've got here, we've got the control panel, pretty much the same as previous videos, except for the addition of these 4 lightets down on the corner. And up here we've got our 3 loops of N-gauge track. This is represented by the layout you saw in the video. And then running around outside of that N-gauge layout, we have a 3-rail loop of track with our O-gauge MTH dockside loco running on it, and that's the analog loco. These 3 locos are DCC. This is an analog loco, that is to say it doesn't have a decoder, it's not DCC, so we've got a AC power pack over here putting power into the track, and then down here we pull power back off that center rail again, go over to the AZA-Trax relay, which is this thing with the orange thing here, and then we go back out of the relay to the center rail of the stop block. So we can use this relay to turn the stop block on and off. In the relay, this relay is meant to be operated by it's a 12-volt DC relay, so it's meant to be operated by a pulse of 12 volts. And what does that in this video is this NCE switch cat shown here. The switch cat operates off of DCC, and it's hooked up. The gray wires aren't really prominent, but there's 2 wires going from the switch cat up to the AZA-Trax relay, and that's what's operating at that relay. But the switch cat itself is sitting here, and that's operating off of DCC track power. These red and blue lines, the color code for that means it's a DCC track power, which we show coming in on the drawing over in the lower left corner here. And we've also, as we showed and demonstrated in the video, we have these push buttons on the bottom. They're shown connecting on the bottom of the switch cat. You can connect push buttons to operate this switch cat manually, which is what we were doing. And then up here we have our speaker that was making the announcements. That's shown here. We have our status light shown here, and that's operated by this one NCE light it, which is set to Loco mode, so we can operate the red light and the green light independently of each other. Down here on the control board, we have the 4 lights that are operating in accessory mode, and we can turn these on and off using the LEDs built right into the light to show which tracks are being activated. And we're bringing the DCC track power in over here to the light. It's into the end of this one and daisy chaining down to the others. Other than the light, this control board is about the same pretty much as about the previous 3 or 4 or 5 videos. We've got our programmable train controller, our NCE mini panel sitting here. We got 3 Atlas 205 slide switches, which give us a total of 9 buttons. Then we've got an Atlas number 56 push button switch over here, which we use to either do the start function when it's down here or the reset function when it's up here. And all these slide switches they're numbered 9, 10, 12 up to 24. All they do, they're connected to inputs of the mini panel, the controller, and all they do when you push them to the on position, which happens to be down toward the camera, toward the controller, when you push them to the on position, they just ground an input, and that's how you direct this controller to do different things. You check like input, if input 9 is grounded, we go around and do it again. That's our repeat switch. That's our repeat switch. And here we have a typical 8-position terminal block. But going back to these buttons, we've got buttons on the end labeled also 1, 2, 3, and 4, and that's to indicate the 4 tracks, so we can run any one or all 4 of these tracks sequentially, one after the other, one at a time, that is, by using these 4 buttons. And we can turn the announcements on using these 3 buttons here. Actually, you really only need 1 button to have the announcements on or have the announcements not on. I just had the 3 buttons, so I gave 2 of the trains their own announcement button, and the two Choreo Locos with the sound decoder, I put them on this 1 button, but you only need 1 button really for all the trains. Then the other option, we had that option where we could run all 4 trains at once if we wanted to. That's this we called this run all 4. That's this button. So if we close this switch 10, it'll start up all 4 trains at once. And then switch 9, which is hooked up to input 9, that's our repeat button, which if we close that, it'll cause the system keep running continuously. But if we leave it open, it'll run 1 cycle and quit. And then over here on the terminal block, we've got the Z-Stuff detector on track 3, and that comes in and connects to I think it's terminal 6 here, and that's how we sense when this detector's been activated. The other wire comes into the ground. These 3 terminals here are ground. And then we've got our public push button connected to that's shown over here, so we can have 1 or more buttons somewhere that the public or your guest, if it's a home layout, can push to start this thing up. And let's go back. We got our 3 loops of N-gauge track. Tom Martino, when he was running this on the display at the Toy Train Expo, he was running 3 DCC trains, so we had terminals for each track. But since we're using it in this video for DCC, I just jumpered all the pluses together and jumpered all the minuses together. That way we can bring just 1 pair of wires in to power all 3 of these locomotives. And you can see here's the 44-tonner up on the top loop, track 1, that Choreo Elko diesel on track 2 with the sound, and that Choreo Union Pacific diesel on track 3 with the sound and with the detector. And then down here is the MTH Loco. I believe that's just about all the components we should be talking about that I can think of. we got a color code for our wires. We got red and blue is our DCC track power, and then violet and green is our AC track power. If we look over here, we can see we're using green to connect to the outside of the 3 rails, which is typically your common or your ground. And in the center rail we show as violet. So, and then we got another track connector down here. We pull that off with a violet wire over to the relay and back out to the stop block. And so that color code explains that. And then our bookkeeping, it's a good idea to try to keep track probably of what your accessory numbers are, just so you don't get confused. But we have accessory numbers 1, 2, and 3, and 4 for these 4 lighted. That seemed to be the easiest way I could think of, was just to call them by their track number, since they're representing tracks 1, 2, 3, and 4. And then accessory 5 is the switch cat that's controlling this relay that's controlling the analog engine. So that's what accessory 5 is doing. And then we have a Loco 999 for our status light. That's just lighted here. We have Loco 9999 for our announcement decoder. That's over here. That's the ESU sound decoder. And in our 3 DCC locos, we have Loco 3 on track 1. We have Loco 74 on track 2, and Loco 957 on track 3. So these are all the numbers we have to keep track of and make sure we use correctly when we're actually entering our commands into the programmable train controller. Let's look at the parts list for this setup. And again, this should be in album 849 on AutoControls-dot-WordPress.com. Our control panel, we got the NCE mini panel, our programmable controller. And this parts list is only going to be approximate, but it can serve as a starting point. And that has 3 of the Atlas 205 control switches on it. That's a slide switch with 3 buttons. It's got 1 of the Atlas number 56 momentary switch. That's the 2-position switch that's used for the start and the reset. It's got an 8-position terminal block. It's got a wood base. I'm using one that's approximately 6.5 by 13, which is really tight. It'd probably be better to use a slightly bigger base. And we got 4 NCE lights, and those are to display which of the 4 tracks is active, and they're operating in accessory mode. So that's sort of a rough idea of what's on the control panel. Now the command stations, in the video we used an NCE power cab, and that includes the PCP, the power control panel. And if you had big DCC engines that pulled a lot of amperage, you probably want an NCE Power Pro command station, either 5 amps or 10 amps. Then the second thing we really ought to have is a second NCE Pro cab for programming. So you've got, in the case of this setup, you've got the power cab for running trains when you need to turn a loco on or move it. And then it's good to have a second Power Pro cab to plug in to do the programming. You can get by with just one, but it's kind of clumsy. And number 3 is our status light and relay. And in this video, we combined those all on the same board with part 2, the power control panel from the command station. But at any rate, we've got our red-green block signal, which we're using as our status light, and you can find these on Amazon.com. The one I got's a metal one. It's kind of nice and sturdy, but it's from South Bend Signal, which is no longer making those things. And then second, we've got another NCE light, a 5th one, to operate the status light, and we're using that one in loco mode. We've got an 8-position terminal block, and we've got a wood base, approximately 6 inches by 8 inches, or appropriate. It could be larger. And note, we probably want to use one relay and one switch cat for each analog train. We just had one relay and one switch cat here, but if you had, like, say, 5 analog trains, 6 analog trains, you need 6 relays and 6 switch cats. So here's our relay, the AutoControls.com LARY, and I believe that's short for, the LA is latching, the RY is for relay, DC, double pole, double throw DC latching relay with an 8 amp capacity, and that's to control the analog train. And there's other options for latching relays. And in our NCE switch cat accessory decoder, and that's to control the AutoControls relay or whatever relay we pick. Then we have our announcement decoder, and this was all done by the engineer named Blake George. It's not something I would be capable of doing, but he used an ESU sound decoder and a speaker and a terminal block and then a wood base. That's basically what makes up that unit. And then we've got our detector unit, and what we used, and this was used on track 3 with that N-gauge Union Pacific passenger train. We used a Z stuff infrared detector. You could use, reed switches, photoelectric eyes, whatever detection means you prefer. I find the Z stuff the most convenient for the way I work. But we were using it for this video. We used a GZ1012 block signal detector, and you could use the DZ1011, which is their earlier model. The advantage of the DZ1012 is it's lower and the light is brighter, and it also has an adjustable time delay for when the relay points open again. You don't really need that for DCC, but you can use it in the DC or AC world for controlling 2 trains on the same track in analog mode. We actually demonstrated doing that. I think it was video 668 or 669. We used that DZ1012 to control 2 locos on the same track, analog locos. Anyway, our relay is a Z stuff DZ1011, and we have we have a terminal block. I think it's an 8 position, and a wood base. What I say, 1 3/4 by 6.5, and you can look for the Z stuff drawings in album DZ1011, which is on that same documentation website, AutoControls-dot-wordpress.com. And then finally, almost finally, you've got the push buttons with a public. You've got a push button and a wood base, and you can actually have multiple ones of these because it's right now, as shown in the video, there's a push button on the control panel and then this public push button. So that's 2 of them in parallel, but you could have 3 or 4 or 5 of them in parallel. So anybody standing anywhere on the layout where there was a push button could push that and start this thing up. Then finally, I just called this locos and other miscellaneous stuff, DCC locos. In the video, we had 2 Choreo with factory sound and a Bachmann with no sound. We used for our analog loco, we had an MTH O-gauge yellow Docksider, and then track cars wire and screws as needed. And as I mentioned, you could use this thing probably for 6 or 7 up to 6 or 7 analog locos. You might not even be controlling any DCC locos. You would just use the DCC part to run the light. It's assuming you wanted to indicate which tracks you were using, but you could use relays to control a whole bunch of analog locos. But again, instead of turning everything on all at once, you choreograph a little performance. Here's the flow chart for this system we've been showing in the video. First thing we do is we push the start button, and that changes our status. And next we change our status light from red to green to show we're operating. And then we have these 4 switches here, 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 and here for the 4 tracks. And if these switches are closed, we'll run all 4 of those tracks, 1, 2, 3, and 4. If a switch is open, it'll just skip down to the next track. But let's assume they're all closed. So for track 1, we go over here and we turn light at 1 on to indicate we're running track 1, and we select Loco 9999, which is the announcement decoder. Then we test to see if the announcement switch is closed. Let's assume it is. So we go over here and start our announcement. We delay for 17 seconds, which is approximately the length of the announcement, because we don't want to start running the train until the announcement's done. And then we come down here. If we had the announcement switch open, it would just skip playing the announcement and go right to selecting the Loco. But at this point, we'll select Loco 3, which is that red 44-tonner, and it will say speed 14, delay 18 seconds. This is the run time here. It'll run for whatever amount of seconds this is set for. Then when we're done running, we say speed 0, delay for 4 seconds. That's just to let it get stopped and everything. And the last thing we do is we turn light at 1 off to indicate we're done running track 1. So let's get down to track 2, and we'll do basically the same thing for track 2 as we did for track 1. We're going to turn light at 2 on, select Loco 9999, the announcement decoder, start our announcement, delay for 29 seconds here because that's got a longer announcement in it for this track 2. Then we'll select Loco 74, which is the red PA, speed forward 8. Now this Loco has sound, so we'll do things just a little different. We'll delay for 9 seconds in this case. Then we'll blow the horn for 3 seconds. Then we'll delay for another 9 seconds. And then we'll set the speed to 0 to stop it. So what we're doing is we're starting it up and running it for 9 seconds, blowing the horn and running it for another 9 seconds. So you can modify these delays however you like, but basically we're blowing the horn in the middle of the run. And then we have a delay of 4 seconds at the end to make sure it gets stopped and everything. And we turn light at 2 off to indicate we're done with track 2. So now our flow goes around and up to the top here, and we're ready to start with track 3. Now again, we're up here at track 3, and let's assume we close the switch for track 3. That's switch 22. It does almost the same thing as before, almost. First we turn light at 3 on to indicate we're running on track 3, select our announcement decoder. If that switch is closed to play the announcements, we start the announcement, delay 16 seconds till the announcement for that track plays. Then we select our Loco, which is that yellow E9. We start it up at a speed 8, and then we do a delay of 17 seconds. That lets the Loco run for 17 seconds. Then we blow our horn for 3 seconds, and then we run for another 9 seconds. Now what we do differently, this is the track 3 where we had that Z-step detector sitting alongside the track. We can use this command, wait till input 6 goes to ground. So once it gets to here, it'll wait till the train goes past and blocks that detector. That is to say, changes it from green to red, which will close the relay on the Z-step detector board, and that'll ground input 6 on the programmable controller, the mini panel. So we'll start another delay of 8 seconds, and then we'll send the stop command speed 0. And what this allows us to do is control where that train stopped. with this Santa Fe engine over here, we could just run on time only. And this one also, we could run on time only. We really couldn't control where they stopped. But using this detector, we can start a time delay from the point we pass the detector, and then we can position the train pretty much wherever we want to. So we've done all that. We delay 4 seconds at the end to allow the train to stop and everything. And then we turn light at 3 off to indicate we're done running track 3. Now that brings us down to track 4, and this is our O gauge loop where we had that MTH Docksider, which has no decoder in it. That's not a DCC Loco. We're just running it off of an AC American Flyer transformer. So we'll control this a little differently. But again, we check to see if switch 24 is closed, which means we want to run track 4. So we turn the lighted on for track 4. Then we select our announcement decoder. Assuming our announcement switch is closed, we start our announcement, and then we delay for 23 seconds till the track 4 announcement is done. And then we get down here and we say accessory 5 norm. That controls the switch cat, which is controlling the AZATRAX relay. So what this does, it turns the relay on, which starts the train. So it pulls out of the stop block onto the main line. Then we have a delay of 20 seconds, and that's our run time. The train will run for however long we make this delay. And then after that delay ends, we'll say accessory 5 reverse, and that causes the switch cat to flip the AZATRAX relay back the other way, which will turn the stop block off. So the train will stop in the stop block whenever it comes around the loop the next time. So the train, after this happens, the train can be running on this little layout you see in the video for maybe up to 6 seconds. But if you had a big loop, it could be running for half a minute or more till it gets to the stop block. And again, we got a delay here at the end just to let it get at least part way back to the stop block and get stopped. And then we turn light at 4 off to show that we're done running that track. Now we're ready to talk about switch 10 over here, which is our run all 4 switch, which means we'll start up all 4 locomotives simultaneously. That's not train choreography. We're not running our little choreographed program for our viewers anymore. We're just starting everything up all at once, like people have traditionally done, but we do have that capability. But if that switch is closed, and that'll be normally open when you're using these 4 switches, and likewise, if you're going to use this program, you probably want to have these switches open. So if that switch is closed, we're going to go down here and we're going to turn light at 1 on, select Loco 3 and start it up. That's the track 1 44-tonner. Same thing on track 2, the red Santa Fe. Turn the light at 2 on, select the Loco, start it up. Track 3, we're going to turn the light at 3 on, select the Loco and start it up. And then track 4, we're going to say accessory 5 norm, which throws our relay to start our analog train up. And then we're going to turn light at 4 on, which we haven't done yet. So we've got all 4 lights turned on at this point, and we got all 4 trains running at this point. So next thing we say, delay 30 seconds. That'll keep those trains running for 30 seconds. And you can adjust this to 60 seconds or 90 seconds or whatever. And what that would do, if your visitors push that all 4 button, that would run them for 30 seconds as shown here, or 60 or 90 seconds, and then they'd shut down again if this switch was open. But if your switch is closed, the repeat switch, it'll check that. If it's closed, it'll go up here and just do these commands again. It'll give it another 30 seconds or whatever this is set for. So if the repeat switch is closed, it'll keep running all 4 trains continuously, checking every 30 seconds or so. until we open the repeat switch. Now, if the repeat switch is open, or if we run it for a while and then we open it ourselves, we come down here to stop all 4 trains. And we set accessory 5 to reverse. That stops our analog train. We say speed 0. That'll stop Loco 957 because that was selected previously. We don't need to put another select command in there because it was already selected, and your programmable controller remembers what Loco you last selected. So we've got 2 of the trains stopped. The other 2, we select Loco 74, that's the red PA on track 2. Then we select Loco 3, that's the red 44 tonner on track 1, and we give those speed 0 commands, which stops all those 4. And then the last thing we do is we turn the lights off. We just say turn light at 1 off, then 2, then 3, then 4. So at this point, we've got all the trains stopped and all the lights turned off. Now you may notice if you look close, there's a little box over here not connected to anything. It says turn all 4 lights on. It's in step input 27, steps 1 through 4. That's just kind of a little test routine I added. I had 4 empty spaces, and I can't access this with a switch. There's not space enough to put a switch in. When I say not space enough, I mean there's not enough space in the mini panel, the controller, to program a way to get here. So we have to run this from the test routine. We just say test input 27. So that's what it's doing. That's what that's doing over there. Now the next thing we're going to do is we're going to go down to our repeater shutdown test. Now we just finished talking about our run all 4 test, which got us down to here. But let's assume we ran it how this thing is normally designed to be operated, running 1 train at a time. In that case, we would have run train 1, done this stuff, run train 2, done this stuff, coming up here to track 3, done this stuff, and come down to track 4 and done this stuff. It would have gone up, and we normally run with this switch open to indicate we don't want to run all 4 most of the time. So it would just drop out and come down here to the bottom, which brings us down to our repeater shutdown test in it. So that's what we'll talk about now. Here's our repeater shutdown test. It comes in here, and we blink the mini panel LED, and then we delay a ½ second, and then we go, assuming the detector's not blocked, we'll talk about that in a minute, but assuming it's not blocked, it goes through here and over to this test, which is an important test. It says it's repeat switch number 9 closed. That's our repeat switch. If that's open, it drops out the bottom, changes the status light from red to green, and then it ends the program. However, if that's closed, it goes over here, and it goes back up to the top of the program, off the top of where we can see it, and it starts everything over back up here at the top. So that's how that works. Now let's talk about the detector test. If we have all these switches open up here, if we have switch 1 for track 1, track 2, track 3, track 4, and the run all 4, if all those are open, it won't run any trains. It'll just keep looping. And if this is closed, it'll loop around and come down here. And if this is closed, it'll go back up to the top. So it'll be repeating the program very fast. And we have a ½ second delay here after it blinks a mini panel LED. And we showed this when we showed the detector test. It blinks about every ½ second when you do the detector test with all these switches open. And then we can test the detector using this. If the detector is blocked, that's when we put a note card in front of it, or if a train is in front of it. If it's blocked, then it goes out to yes side here, and we add an extra second of delay and that slows down the blinking. If you've seen any of the previous AutoControls-dot-org videos, the last 8 or so of them, we've used this similar test. It'll blink at a half second when the detector's not blocked, and if you block the detector either with your hand or a note card or a train, it'll add this extra second delay in and slow down the blinking, and that's how you can do a quick test to make sure your programmable train controller is seeing, so to speak, communicating with the detector. And then over here, we've got the same thing we had on the wiring diagram, just a list of all our accessory decoders and what Locos numbers we're using. 3 of these are the Locos on the track, the last 3, and then these 2 are for our lighting and announcement decoders. And accessory 5, that's the switch cat for track 4 that operates the relay. We already talked about that. Let's take a look at what we call the command file for this setup. The first page is basically some notes and a picture of the setup and some more notes about the settings of the engines. The second page is a picture of our wiring diagram. We've already looked at that before. And in the third page, is some more notes and bookkeeping. Up here in the corner, on the third page, up here in the corner, we've got some bookkeeping, basically a tabulation of our inputs and what subprograms are in those inputs. And we have, as you recall, probably if you've used this mini panel, we have inputs 1 through 30, and actually we do have a 31st one, which we can use if we use it carefully, we think. At any rate, Program A, which is track 1, takes up 4 inputs. Program B, which is track 2, takes up 5. That's running the DCC Loco with sound, that red Elco PA. Program C for track 3, that's the Union Pacific. That takes up 6 inputs because we got the Z-Stuff detector hooked up there. And in our track 4, which is our MTH analog train, that takes up 4 inputs. And in our run all 4 tracks at once, Program E, that takes up 6 inputs. So basically we had this thing full as we're using it. It takes up about 3 inputs at the end to do our end of the program shutdown or repeat, plus our detector test. And then this part's just a tabulation of what the different slides buttons do. This kind of really duplicates what's on the wiring diagram. And in here we have the configuration settings, which are mostly default except for 2 of them, and you want to make sure you've got these set the way you want them. We change memory address 3. This is in your configuration settings for the mini panel. We change memory address 3 to 1. The default is 0. And this makes it continuous memory for inputs 1 and above. If you don't do that, every 4th step you got to use a link statement, which uses up a bunch of space just to write your program. And in the memory address 4, we set that to 2. And again, the default's 0, but we change it to 2. And that says we're going to disable inputs 2 and above. And by disabling them, it means it won't be polling them to look for a push button that's pushed. We can still query them when we're running the program, like is input 6 ground or not. We can query them, but it won't be looking for a push button. Because the way we do this, we only use 1 push button on input 1, and then everything above that's controlled by slide switches. But say if you were using 3 push buttons like we had to do, I think it was video 824, we did need 3 push buttons, so in that case you'd have to disable input 4 and above, so the first 3 would still be active. And in this last part down here where it says examples of commands, that's basically a library. These are all the common commands that I find myself using to write these programs. I just wanted a handy reference so I don't have to go digging through the mini panels technical reference manual to find them. Next page here is our actual program, and I probably should try not to spend too much time on this since we already spent quite a bit of time on the talking about it on the flow chart, which is kind of the same thing. But here's the beginning of the program, input 1, step 1, and we turn on our status lights. And like I mentioned, we actually have 2 of them here. I kind of like using the lighted. I think that's an easier way to use a status light, but we use the lighted, which is the first one, and the sound decoder, the lighting function on that one, so we actually have duplicate lights for this video. And in our first train is this 44 tonner. That's track 1, and that goes from here down to here. And this line I yellowed is our skip statement, which corresponds to the yellow triangle on the yellow diamond on the flow chart. If that switch is open and it hits this skip statement, then it doesn't skip over this linked input 6, so it goes down to the next one. But assuming this is closed, it won't skip over that linked input 6, and it'll perform these instructions. We got this many for station departure announcement, and then we're running our train, and this has no sound, so we just select it, turn it on, let it run, and then stop it and turn our lights on and off at the beginning and end. And in our next program, going down to that, we come down here, and it's kind of similar. We have our station departure announcement, and we start the second train. And the only thing we do different, because this is a sound loco, we can blow the horn. So we run it for a short time, blow the horn, run it for some more, and then stop it. Now we're running track 3, which is that yellow Union Pacific loco, and this is similar to the previous track 2, except we've got the detector alongside this track. And if you recall, we said we could use the detector to park the train where we wanted, so we still have our station departure announcement commands, which are here. Start the third train, blow the horn, and then delay some more, but then we wait until input 6 is ground. That says wait until the detector is activated, goes to red, closes the relay, which will ground our controller. So when that happens, this statement's satisfied, and it goes on to this. We delay 8 more seconds, which on this layout's amount of time needed to bring it around to the front of the layout, and then we stop it. So with the detector, we can always assure we stop it on the front of the layout. With the first 2 trains, we had no detector, so they kind of stopped wherever they stopped, and sometimes they end up on the back side of the layout. With the Santa Fe train, it could be hidden behind the mountain. And then now we'll go down to running our last track, which is track 4, which is our analog track. And in that case, we do our station departure announcement the same as before, turn on our light. In this case, because this is an analog train that's controlled by the switch cat and the AZA-Trax relay, we just set the relay to normal. We say accessory 5 norm, which turns on our relay. We run the train for a certain amount of time, say accessory 5 reverse, which turns off our relay. Then we have a certain amount of delay to allow it to get around to the stop block. Remember, there's a stop block, but when the relay turns the stop block off, if the train's on the other side of the layout, it's going to keep running until it comes around to the stop block. But the important thing to remember is we can use the stop block to position this analog train where we want it to stop every time. So now we're down to what we call our run all four part of the program. This is Program E, controlled by switch 10, but this is where we turn all four locos on at once and just set them running all four at once. This is basically not trained choreography. There's no choreographing or performance. Everything's just running all at once, but we have this capability. And if we wanted to run more engines and we're running four, we can move this to a second mini panel. It doesn't have to be in this one, but since we had the space here, I put it in. But basically all we do is we turn the lighted on. In this case, this is the lighted for track 1. We turn it on, start the first loco, turn the lighted on for track 2, start that loco. Track 3, turn that lighted and loco on. Track 4, we say accessory 5 norm, which turns the train on. Accessory 4 norm, which turns the lighted on for that track. So at that point right here, we got all 4 trains running and all 4 lighteds lit on the control board. So we got a delay a quarter second times 30, which is a 30-second running time. And in here we have a check of our switch 9, which is our repeat switch. This normally happens at the end of the program, but we're checking it here in the middle of this program to see if we want to repeat. And if that's closed, it goes back to the top. Right, you shouldn't say the top. It goes back to step input 24. It runs for another 30 seconds. So if we keep this switch closed, the repeat switch, it'll keep running this routine right here for 5 minutes or 10 minutes or however many minutes. And then if we open the repeat switch, it won't skip that anymore. It'll skip it. If it's open, it will skip that link statement. So it'll go down here. I'm off the camera. It'll go down here, and we come to our stop routine, and basically it stops all 5 trains. And notice here, input 25, step 3. I mentioned this in the flow chart, but we don't have a select statement. We just say speed forward 0 because the last loco we selected was 957. So 957 is all still selected. We could just say speed forward 0, but then we have to select our other 2 DCC locos. And of course, if we accessory 5 controls our relay, so we say accessory 5 reverse, which opens the relay and turns the stop block off for the analog train. So what we just looked at, we had all 4 trains turned off, and the last thing it said on the previous page, I forgot to mention it, but it said linked input 28, which brings us to here. The trains are stopped, but the lighteds are still on, so this program H just turns off our 4 lighteds, and then we're ready to go into our repeater shutdown test, which is down here. But let me mention this, there was one empty input here, 27, and I put in 4 statements to turn the 4 lighteds on. And like I mentioned when we talked about the flow chart, you can't reach this with any switches. There's not room to put a switch to get you in here. When I say a switch, I mean if a switch is closed, linked to input 27, there's nothing available. So the only way you can execute this little routine is just to go into test mode and test input 27. And all that does, it just turns on all 4 lights at once. It's kind of a test. Now we're down to the bottom of our program, to what we call our repeater shutdown test. And it comes down here, and if our input 9, if our slide switch 9 is closed, it hits this link to input 2 statement that goes back to the very top and does everything all over again. However, if our slide switch 9 is open, that's what we call our repeat switch. If that's open, then it goes down here and it shuts everything down. Basically what we're doing here is turning our 2 status lights from green back to red. and we have the detector test built in here. If we have all the switches to run the locomotives open, but we have the repeat switch here closed, it's going to try to loop real fast, doing the program from top to bottom, and that's why we got this 1/4 second times 2 delay. It can't run at infinite speed. I found it runs for about a second and it just quits. But if you put a half a second delay in here, which is what this is, it'll blink the LED on the mini panel about every half second. That's what this accessory 2000 norm does. That's a non-existent turnout. We send a command which makes the LED on the mini panel blink. Now, if we block our detector, or if we're doing our detector test, if we block our detector, it adds an extra second delay here, and that's what slows the blinking down when we do our detector test. So this is basically the end of the program. And notice we're in input 31, which I've always said in the past to avoid using, because this input supposedly executes when the mini panel powers up, but I got stuff in here that's not going to do anything. It'll do a couple things and then end anyway, so it seems to work okay. But I just have a note here to be careful when you're using input 31. And if you wanted to control more trains than what one of these can control, you could probably use 2 of them and have the first one run 4 or 5 locomotives and then hand off the program, so to speak, to the second one and have the second one run some more. You basically have the mini panel close a relay connected to input 1 on the second one, which would essentially be the equivalent of a person pushing the start button, but the first mini panel would essentially start the second mini panel. I think that would work.